So let me see, is everything working according to the plan? Can you see my full screen?
It's not, yeah, perfect.
All right, thank you very much. So as the title says, this is an exercise, so it is definitely a preliminary work. And the motivation for it is, it stems from the observation that in everyday life, we are very often confronted with situations where we know too much about something, right? To the extent of getting contradictory information. Or sometimes we know very little about something, whether something is true or not, so that we can't really take these decisions. And of course, this is a challenge for human reasoning, which has also been carried over to many AI applications, in particular to logic-based AI, right? So of course, these issues have been dealt with in the literature, and many approaches have been proposed. And in a sense, most of them consist in workarounds, or maybe many of them just assume that, okay, there are these limitations to classical reasoning. We can't do much, so let's do what we can. So the goal of this preliminary work consists in revisiting the foundations of the semantics of classical propositional logic in order to hopefully provide a simple framework within which we can deal with inconsistency and incompleteness. So I'm going to start by presenting the basic semantic framework, right? So here we assume as a starting point the language of classical propositional logic, which is built from a finite set of propositions or atoms, right? Using the standard Boolean connectives, okay? Now, according to the classical semantics, the notion of valuation or world is that of a total function, assigning either true or false to a propositional atom. So over here, we want to generalize, in a sense, this notion and relax it so that a world or a valuation now becomes a relation. Okay, so it's a relation between atomic propositions and truth values, right? So that, of course, gives us a much larger set of possible valuations, okay? And then the idea is that a given propositional atom can be assigned either true or false, or both at the same time, or neither, okay? Now, it is convenient to classify, to separate these different valuations into different sets. So later on, we are going to make use of the classical worlds. So they are worlds that are classical in a sense, they are total functions. We also have the partial worlds, those corresponding to partial functions. The absurd worlds are those that assign more than one truth value to a given propositional atom. We also have the possible worlds, consisting of the classical and the partial ones, and the non-classical worlds are all the worlds that are not classical. Okay, so now once we have generalized the notion of evaluation, we look at the notion of satisfaction. And again, in the classical case, satisfaction is seen as a total function. It's an all or nothing notion, in the sense that a sentence is either satisfied or not satisfied at a given world, right? So over here, we want to relax this notion again, right? One of the issues is that of compositionality, basically how to determine whether a sentence is satisfied at a given world in terms of how its sub-sentences are satisfied or not, right? So there have been some approaches trying to address precisely this issue, and they stumbled upon the so-called exportation principle. So that means if you have a sentence that is contradictory, right, and then you want to decide whether it is satisfied by a word or not, in terms of satisfaction of its sub-sentences, you end up realizing that their sentences, their sub-sentences are satisfied if and only if they are not satisfied, in a sense. So that means the meta language, the language that you are using to talk about satisfaction, gets contaminated by the contradiction at the object level. So we want to avoid that precisely, right? So then the definition of satisfaction in our case is precisely what it is. It's a binary relation, right, between sentences and words and truth values, okay? And then we say that a given sentence alpha is true if it is assigned 1, it is false if it is assigned 0. And of course, it can be true, false, can be both, can be neither at a given world. And it's important to notice here that to be false does not mean not to be true, right? So that's one of the important points of our definition of satisfaction. Now, once we have defined satisfaction, then we can summarize the behavior of our Boolean connectives in the truth tables that we have over here, okay? So, okay, I don't have time to go through all of them in detail, but roughly, in a sense, they relate very closely to the truth tables for the same connectives in a 4-valued logic that has been around for a while, proposed by Belknap and studied by Dunn many decades ago, right? With the difference that over here, we don't assume extra truth values. We have only true and truth and falsity, right? And it's just that they may occur together and they may be both absent from the table, okay? Now, we can have a look at a few properties of this semantic framework. So the first one relates to complexity of reasoning. Of course, since we are dealing with an extension of the classical case, we already have a lower bound. Now, for the upper bound, clearly we have a much larger set of valuations to consider, right? An exponential number of them, but it can be verified that if I have a valuation and a sentence, checking whether it satisfies the sentence can be done in polynomial time, right? So in that sense, the satisfiability problem in this semantic framework remains an NP-complete problem. Now, how do we deal with the exportation principle? So assume that we have a sentence, alpha, and its negation, right? And that we assume that both alpha and not alpha hold at a given world, right? So then, according to our definitions, basically this means that the value 1 is assigned to the sentence. And then if we look at the tables, we can, in a compositional way, we can determine the truth values of alpha and not alpha. And in the end, we realize that both alpha and not alpha have as truth values 0 and 1. And then there is no contamination of the meta level language with the contradiction in there, right? Now, in terms of some of the well-known equivalences and laws inherited from classical logic, we have that all the De Morgan's laws are preserved. And as it turns out, material implication is a superfluous connective. Also, if we assume the bottom constant over here, negation becomes obsolete as well. And as it turns out, there are many tautologies in classical logic that usually are seen as problematic, and they do not hold in our semantics. Also, another interesting feature over here is that there are many sentences that are syntactically different, okay, but which are semantically equivalent under classical semantics. It turns out that in our semantic framework, we are able to distinguish between them, right, whenever it is necessary. Okay, now to come to an important question from the point of view of reasoning. So once we have a sentence or a set of sentences, if you want, then an important question becomes, what does follow from the knowledge that we have from our premises, right? So if we have some sentence alpha, we are interested in what follows from alpha. And the usual approach is to look at the alpha models, okay, and check whether a given sentence beta holds in there. Of course, the different choice, the choice of which alpha models we want to work with determine different forms of entailment, of consequence, right? So we have some obvious candidates. We can look at the classical alpha models, the partial ones, the absurd ones, the possible ones, and so on. We can look at all of them, of course. And over here we have had a look at two new, but including classical entailment as well, 3 forms of entailment. Okay, so the first one is just classical entailment. We look at the classical alpha models and check whether they are beta models or not. Possible entailment considers the possible models of alpha, right? And general entailment is about all the alpha models. So the idea is, with these obvious candidates, we get, in a sense, a skeleton of a possible full spectrum of entailment relations, right? In this case, general entailment is a proper subset of possible entailment, which is a proper subset of classical entailment. So it becomes interesting to study what other types of entailment, notions of entailment, lie in between each of them, okay? Now, in terms of properties, with these definitions, with these preliminary definitions, we already managed to get rid of some undesirable properties of classical logic, right? They do not hold for general and for possible entailment. On the other hand, they still satisfy some of the properties from classical reasoning that are seen as cumbersome, for example, monotonicity, right? There are also, depending on the application that one has in mind, there are some desirable principles of classical logic that we lose by considering either general or possible entailment. In either case, we believe that even though general entailment is too weak, it still should be the basis, right? The bottom, the lowest level to consider, because it's the most general form of paraconsistent reasoning, in a sense, since it allows for absurd worlds to be taken into account. And for practical applications, we believe that possible entailment is a good trade-off, in a sense. So then the question now is, what else can we find between the two, right? So this is one of the open questions. So to conclude, so we have revisited the semantics, the basic, the semantic foundations of classical propositional logic, and we have generalized the notion of valuation and of satisfaction at a given world, right? And we have seen some notions of entailment based on the semantic constructions that we have introduced here. Now, as for the next steps, of course, we shall look at alternative notions of entailment and also investigate their respective proof theories. So there seems to be a close link between the general entailment and the well-known logic of first-degree entailment, in which relates to, again, to the four-valued logic that I briefly mentioned. Now, of course, a comparison with other non-classical systems is still in order, right? So that we can provide a complete picture of the whole thing. Also, generalization of the set problem to this more general framework. And perhaps the most interesting and exciting open questions here is how to bring in some extra structure to the semantics. For example, one way to do that is to bring some notion of ordering, so that we can rank the different valuations in terms of how plausible they are, right? And with that, we can get to different notions of entailment that are informed by the information encapsulated by the ordering. And then, hopefully, that will also help us to shed some light on work that has been done on belief change and non-monotonic reasoning, now with a semantics that goes beyond that of the standard classical semantics. Thank you very much.
Yeah, thank you for that. Tommy, do you want to ask your question?
Yeah, sure. I have two questions, in fact. So I'll ask my first question, and then we can have a look and see if there are other questions as well. And if I still have an opportunity, and I think we have enough time, I'll probably get to my second question as well. So the first one is, as we've seen at this conference, we've talked about interdisciplinary work and cross-disciplinary work and transdisciplinary work a lot, which I think is a good thing. Now, if I look at the philosophical side of many of the things we've talked about over here, the one thing that no one has said anything about is postmodernism. Now, I must admit that I know and understand not that much about the postmodernist tradition within philosophy, but I'm wondering whether the kind of semantics that you have here cannot be used to try and formalize a version of postmodernist thinking. I'm not sure whether this has been done at all, but what are your thoughts on this, Ivan?
Okay, thank you for the question. Yeah, it's an interesting coincidence, because I haven't really, on one hand, I haven't thought about this postmodernist view.
I thought you were going to say yes and no.
I can say yes and no, of course. Yes, I can do that. Yeah, and it's interesting because I see myself as kind of a going through a postmodern phase of my life, even though I don't know much about postmodernism. But in a sense, I have set myself more as a, and please forgive me if I'm saying nonsense, I've set myself the mission to deconstruct the basic foundations of classical semantics and ask the question, but why does it, why must it be like that? Maybe it can be, you know, like this, and then we can see what happens, right? But to come back to your question, so I don't have a final answer, of course, and so maybe I will content myself with just saying yes and no, and there's no exportation principle in my answer.
Okay, I see there are other questions, so I'll hold off on my second question.
Yeah, let's go to Guy, and then we can go back to you.
Cool. Yeah, thanks, Ivan, for the talk. Very interesting. The idea of reasoning with paradox and inconsistency is quite fascinating to me. I'm wondering, so you spoke of some classical tautologies that you view as being undesirable. I was wondering if you could maybe elaborate on what those were and why you view them as undesirable. Just
yeah, there are some paradoxes of material implication that have been already identified by Aristotle a long time ago, and some of them don't hold, right? So I can't remember exactly which ones now. I have to look at the paper. And I have no co-author to help me on this, so so for example, the fact that anything that is true is implied by anything, right? Or that a contradiction implies anything. So this kind of a tautology, right? Something that holds under the classical semantics, they don't hold anymore, because now we have a much larger set of possibilities, and therefore so they are no longer tautologies. And there are other examples as well, which I don't recollect now, but they are definitely in the paper, right?
Okay.
And I'm trying to remember now. There are some okay, I think there are some let me see. Yeah, I forget the exact the technical term now for them. They are quite known in the non-classical community, and but yeah, if you don't mind, please have a look at the paper, then you have more details.
Cool, thank you. It's intriguing.
Just a comment. Besides being a postmodernist, I'm also suffering from memory loss, so that's why the paper was written back in September, so it's been almost half a year now.
Okay, Tommy, do you want to finish us off again? There are no other questions.
I can go ahead and ask my second question. So Ivan, since you started a tradition just a couple of minutes ago of asking a speaker a question about the previous talk, I'm going to follow that tradition and ask you what you think are the directions in which KLM reasoning is going to go into the future. Which are the most promising avenues for research in that?
Yes, and of course, this is a tradition that's going to end with this talk because it's the last talk of the session. But anyway, yeah. So one of the things that I wanted to do in the beginning, and of course that I was not able to do, is to investigate how you can incorporate orderings in the KLM sense, right? In order to get to more powerful notions of entailment in this framework, right? So the idea would be to get a defeasible formalism for defeasible reasoning that would also be able to cope with inconsistencies. And not only exceptionality, as it is already the case in the KLM approach, but to be able to cope with contradictory information, and at the same time that would show some aspects of intuitionistic behavior as well. So that was the original goal, right? Of course, I didn't get there. So my guess is that the one immediate next step would be precisely to bring in, or to take the KLM framework, right, and replace the classical valuations perhaps with these ones, or maybe with a for-valued semantics and see what else it gives us, right? So I think that would be probably the immediate step to make, since we already have a sense of how things work in the KLM approach, so it wouldn't take that long to do that. So that's my view. I wouldn't say it's the most interesting thing from a KLM perspective, right? But it's definitely something that I'm quite curious about.
Fair enough.
So I see we've reached time, but there is one more question if we quickly want to do that before the break.
Okay, I don't know if this is going to be a valid question or not, but diffusible reasoning, all this kind of reasoning, they seem very odd to me. I'm used to classical way of looking at things. But the question that comes to my mind is, can one work in maths? We deal with complex numbers, and sometimes in engineering, you find that you have to go through complex numbers to get better answers to real numbers, for example. And that's what. So I'm wondering if are there ways that one could start a question in, let's say, a classical environment, a classical reasoning environment, and then use techniques of these divisible environments and inconsistent environments to actually get back to answering, having better solutions to classical situations. Hope that helps.
Yeah, if I understand your question well, so if I'm doing mathematics and then at the meta level I use some defeasible form of reasoning, I believe that's not going to be acceptable, right? If I'm doing a proof and then I say, yeah, but then usually when we have this thing, we have that thing, therefore we do that, I think that will be might be an issue. So perhaps it depends on where exactly you want to use these different levels or forms of reasoning, right? But but this is the first one that comes to my mind, right? So maybe when we are doing the meta reasoning, we want to keep some form of classical reasoning in a sense. And we probably don't want, well, okay, maybe, okay, then of course, this is something we can talk forever, perhaps, but if we spot a contradiction, then we probably stop there. We don't want to carry on either, right? So then, yeah, but I see your point, yeah. But right now, my answer would be, in terms of methodology, we should remain classical, so to say, at least for now.
Thank you very much.
So yeah, I think that concludes until the next talk at 3:20.
Thank you.
Right. Thanks, Karen. Thanks, Ivan. We will see everyone back here at 3:20. Yeah. Okay.